Before we start to calculate some annuities and retirement accounts, let's talk about a few different savings accounts. We've calculated simple interest savings accounts where we had a one-time deposit of money and interest was earned one time. This one, the one-time deposit of money, was called the principal. And we also used that principal for a one-time lump sum deposit of money when we calculated compounded interest. The difference between simple interest and compounded interest is that simple interest has a one-time calculation of interest, and compound interest has interest earned multiple times. For example, we had interest earned monthly or quarterly or semi-annually. An annuity has multiple deposits, not one-time deposit, and interest is also earned multiple times. So let's say, for example, you're going to deposit money into the bank monthly, then you'll also earn interest monthly. This is typically how a lot of people would save for retirement. Not a lot of people would have $10,000 that they could just put into an account and leave it to sit there for 30 years. But what people could do is they use an annuity and they say, I'm going to save $200 every month. And every month I'm going to put $200 in the bank, and that $200 will earn interest, and over the course of 30 years, it will become a much larger sum. Let's take a look at some annuities. Similar to previous chapters, a lot of the calculation has been done for you within the tables. So with an annuity, we have an end of every quarter. This is really important. In a few minutes, we'll talk about questions where the deposit's at the beginning. So the end of every quarter, $2,000 is put into a retirement plan that earns 6% compounded quarterly. Find the future value in 5 years and the amount of interest earned. The future value is another way to say the amount of the annuity. So we're going to find the amount of the annuity by finding the repeated payment. In this case, that's $2,000, and then finding the number from the annuity table. If you remember from previous chapters, to look in this annuity table, we needed to find the I and the N. The I is our 6% compounded quarterly, so 6% in the numerator, and we're dividing by quarterly. So 6% is the percentage for the whole year, and we're dividing that into 4 pieces because there are 4 quarters in a year, and that gives us 1.5%. So that's our column. To find the N, or the correct row, we're going to find out how many times interest is calculated over the life of the loan. So it's calculated quarterly, which is 4 times a year, and it's going to happen for 5 years. So that 4 times 5 is 20, and that's the row that we're looking for. So again, our amount of the annuity is going to be the $2,000 repeated payment times the number from the table. Let's look at row 20 and the 1.5% column. 23.12367. So let's bring that back. And now we're going to multiply. The amount of our annuity, meaning its future value, is $46,247.30. That gives us the future value, or the amount in the account. The second part is to calculate the interest earned. I like to calculate the interest earned as a comparison of the money in the account minus the money that was invested, or the money deposited. Now we know the amount in the account is $46,247.30. The money deposited was not a one-time $2,000 deposit, but $2,000 were deposited 4 times a year quarterly for 5 years. we're going to have our $46,247.30, and the amount deposited was $40,000. So the difference in the amount at the end of the account and the money that was deposited is $6,247.30. And this is the interest only. And that's pretty good interest in just 5 years for just leaving your money in the bank. Let's take a look at question 2. At the end of every month, $300 is put in an account that earns 12% compounded monthly. Find the future value in 2 years and the amount of interest earned. So remember, the 12% is the annual percentage rate and it's compounded monthly. That's going to help us calculate the I. 12% for the year divided by monthly. And there are 12 months in a year. So when we divide, we get the 1%, and that will tell us what column to look up. The row that we're going to use is the N, and the N says take our monthly deposits, and we're going to keep our deposits in for 2 years. So 12 times a year for 2 years, we're going to make 24 different deposits. To find the amount in the account, the $300 for the repeated payment, and we're going to look up the 1% column and the 24th row. So down the 1% column to the 24th row, and we're going to take that decimal back to our calculation. 26.97346. And when we multiply, I get $8,092.04. And again, this is the amount in the account. The second part is to calculate the interest. So to calculate the interest, we're going to take the amount in the account and we're going to subtract the money that was deposited. So in this case, $300 was our repeated deposit into the account, and we did that 24 times. 12 times a year for 2 years. So we ended up depositing $7,200, and then subtracting, we end up with an interest of $892.04. In our next video, we'll look up ordinary annuities compared with an annuity due.